Hello, I'm Aisha, and this is my group members, Ranjit, Anas, Khairi, and Tinakaran. Ranjit, Anas, Khairi, and me are from University Technical Malaysia Melaka, and Tinakaran is from Institut Kemahiran Tinggi Belia Negara Sabah. Today, we are going to present our innovation called AgriSnaps, a portable and waterproof IoT weather monitoring system that we designed to encourage farmers to adopt IoT technology in their farm field. In line with the fourth industrial revolution, our government always encouraged the farmers in Malaysia to implement smart farming using IoT for better decision making. However, the farmers, especially in rural areas, refused to adopt such technology in their farm fields, and we were intrigued by why this scenario happened. To better understand, we interviewed some of the farmers and found out that there are four main reasons why they are not ready to implement IoT in their farm field. First, the level of education required in order to get familiarized with IoT technology. Second is the lack of engineering skills to install and maintain the IoT system. Third, if the system broken, how are they going to troubleshoot? And the last one is how much will this going to cost them? Now that we know the concern voiced by the farmers, we decided to design and develop an IoT weather monitoring system as a starting point, since it is the most important variables in growing crops. Being able to closely monitor the weather is extremely valuable to the farmers. It has a profound influence on crop growth, development and yields, on the incidence of pests and diseases, on water needs, and on fertilizer requirements. Therefore, our main objective is to develop a farmer-friendly IoT weather monitoring system called AgriSnaps that allow the farmers to happily and easily understand how to integrate, self-troubleshoot, and maintain the system without requiring expertise on the farm site. To develop AgriSnap, we first designed a color-coded 3D casing for each of the required electronic components: the mainboard casing, the temperature sensor casing, the humidity sensor casing, the rain sensor casing, and the light intensity sensor casing using a 3D CAD software tool. We then place all of the electronic components inside the casing respectively. Each of the casing is enclosed with a screw-fastened cover to waterproof the system. Inspired by the educational STEM toys that use magnets and pogo pins to allow children to combine each electronic toy element, we also implement this method in our design. Pogo pins were used and embedded into the design block to allow the current or signal to flow from the controller block to the sensor block or the other way around. Small magnets were also embedded into the design to enable a solid contact between the controller block and the sensor block. Once all are satisfied, the 3D designs of AgriSnaps is printed out using a 3D printer, and all the electronic components, pogo pins, and magnets are embedded into the casing. Then, we program AgriSnaps to collect the current humidity, rain index, light intensity, and temperature data, which will then be forwarded to ThinkSpeak and Google Sheet platform using Wi-Fi connection. This platform allows the user to visualize a live data stream from any web browser or mobile device. A typical DC power connector is used to power on the AgriSnaps. It operates at 3.3 volts and has a maximum current draw of 70 mA with a power consumption of 231 mW. Generally, the AgriSnap will consume 2.024 kWh over the year, which means that the electricity bill will only going to cost around 21 ringgit and 80 cents per year. Therefore, either using a plug-in power adapter or even a solar power bank, AgriSnap will not going to break the user's pocket. AgriSnap is very easy to assemble, as demonstrated here. By referring to the engraved icon on top of the casings, the user simply needs to bring the controller block and the sensor block and snap it together. As a safety precaution, different magnetic pole combinations are used for each block to avoid accidentally snapping the sensor into the wrong slot that might damage the circuit. AgriSnaps also able to detect which sensor is currently connected or disconnected. In this way, the user can decide which sensors are required according to their farm condition. If the sensors are broken, the user can snap out the broken sensors and simply let us know. We will then send a new one and the user can easily snap it back together again. When moving out, no technician is required for the uninstallation process. The user can just bring along AgriSnaps with them and install it at a new location independently. AgriSnaps is portable, waterproof and durable. The user can simply place it in the required location as long as it is in the open space. To validate the performance of AgriSnaps, we also develop a typical IoT weather monitoring system that integrates the same electronic components as in AgriSnaps. And we compare the sensor reading gained from both systems. Each of the sensor readings from both systems are recorded for 7 days. After that, we did a blown-out analysis to investigate if the sensor reading from AgriSnaps is comparable to the typical system by analyzing the recorded sensor reading. According to the analysis, AgriSnaps produces a low variant, low bias sensor reading compared to the typical system, which means that AgriSnaps effectively able to provide accurate and precise real-time weather monitoring data. And this validates that the AgriSnap performance is comparable to the typical IoT weather monitoring system. We also designed a user experience experiment to investigate the effectiveness of AgriSnaps and invited 10 participants to participate in the experiment. First, we asked them to experience using the typical IoT weather monitoring system for 7 days. Then, we asked them to fill out a user experience questionnaire that is widely used to measure the subjective impression of users towards a product. Then, the process is repeated again by letting the same participants to experience AgriSnaps. After 7 days, they will fill out the same questionnaire again. Once settled, we analyze the user experience questionnaire using the SPSS statistics software. The user experience questionnaire allows the user to give a negative impression if they don't like the product, a neutral impression if they feel the product doesn't impact them, or a positive impression if they really like the product. The results show that the participants' impression of the typical IoT weather monitoring system was mostly negative. In contrast, their impression towards AgriSnaps was leaning towards positive impression. This means that the design of AgriSnaps was very much appreciated and acceptable among the participants. With the cost of around 100 ringgit to fully develop the system, AgriSnaps can improve the farmers' acceptance of using IoT technology on their farm field. In the future, we would like to improve the design of AgriSnaps by integrating solar module so that it can operate independently without requiring an external power source. We also would like to integrate more sensors so that AgriSnap can cater to a different condition based on the crop grown in the farm field. The design of AgriSnaps successfully allows the farmers to easily understand how to assemble, self-troubleshoot, and maintain the system independently without requiring an extensive understanding of IoT technology and electronic concepts. And these features enable the farmers to improve their acceptance toward implementing IoT technology in their farm field. As Milton Glaser once said, there are 3 responses to a piece of design: yes, no, and wow. And wow is the one to aim for. That's all from us. Thank you for being here today. We really appreciate that you took the time to be here and listen to our presentation. Have a nice day!